Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem LeetCode number 18 for sum. So the problem statement says that given an array nums of n integers, return an array of all the unique quadruplets nums of a, b, c, d such that a, b, c, d are in the range 0 to n, a, b, c, d and d are distinct, and sum of all these nums of a, b, c, d is equal to the target, and we may return the answer in any order. So the problem statement just says that we are given an array in the input and a target, and we just have to find the quadruplets such that they sum up to the target. For example, in the example 1, we can see the input array nums is given, and here the possible quadruplets such that the sum is equal to the target 0 is -2. These three possibilities are there, and we can see they are summing up to 0. These are summing up to target, that is 0. So we just have to find these quadruplets. So this question is quite similar to the problem 2 sum and 3 sum, and we will use the same approach here. So what can be the brute force approach? Brute force approach can be, we can go and try all the possible quadruplets, and we can just sum them and check if they are equal to the target or not. So how we will do it? We will just run a for loop. This will first for loop I is equals to 0. This will go up to the last element. Next j will start from I plus 1. This will go up to the last element. Next k will be equal to j plus 1, and this will go up to the last element. Next L, fourth pointer, will be from k plus 1, and this will go up to the last element, and in each iteration we will just check if the sum of all these nums of I, j, k, l is equal to the target or not. If it's equal to the target, we will just save our all the quadruplets in a vector, and at last we will return the result vector. Alright, so but this will take big O of n to the power 4 time complexity. Alright, so how can we optimize this? The second approach, we can think of using hash maps also. This will reduce our time complexity, but they will take extra space complexity also. And the third approach, the optimal approach we can think of is using just 4 pointers, as we do in 3 sum or 2 sum. Alright, the approach, the pattern is similar. We have to just find the pattern. Alright, find the logic. So how we will do this, I will explain you with an example also. So we will use the example 1. Example 1 is given -1 comma 0 comma -1. So here, if I use another whiteboard, here it is given 1 comma 0 comma -1 comma 0 comma -2 comma 2. Alright, now this is given. Let me recheck it. 1 comma 0 comma -1, 0 comma -2 comma 2. What we will do, what we used to do, we using 4 pointers effectively, we have to first sort this array. So after sorting, it will become -2, -1, 0, 0, 1 and 2. Alright, so the first step was to sort. Alright, the first step was to sort this nums array. The second step, we will use 4 pointers. So how will use this? Simple. I will be at the starting 0, j will be at I plus 1, k will be at j plus 1, and l will be at last. Alright, and these I and j will be fixed, and these k and l will be variable, and we will just move them. We will move them, and we will check all for the quadruplets, and if they equal to the target, we will just store them. Alright, so first, here in the first case, we can see what is the sum coming. -2 nums of I plus j plus k plus l is coming -2 plus -1 plus 0 plus 2, and what is the target? Target is 0. So let's save here that target is 0. So this is coming around -1. Alright, so we can see which is less than the target, which is less than 0. So what we can do here to increase the sum is coming -1, less than 0. So for increasing sum, we will move our k pointer forward, and for reducing the sum we will move our L pointer backward. So we will move k pointer here. Alright, now we will check now what's the sum. So now it's coming -2 plus -1 plus 0 plus 2. So this is coming again -1, which is less than 0. Now again we will move k. Now the sum is coming -2 -1 1 and 2. We can see the sum is coming 0 now. Alright, so this is equal to the target. So we will just save these numbers. So the numbers are -2 -1 1 and 2. So let's say, where should we store? I am storing here. Answer -2 -1 1 and 2. Okay, we have got one quadruplet. Now moving ahead, if we have found the answer, we will move both the pointers. Now L will move backward and K will move forwards. Now we can see K has crossed L, so we will stop here because we will move these L and K pointer. We will check only if K is less than L. Alright, so this is over. Now we will just move our J pointer now. So J was here, now our J will be moving now. Alright, now J will be here and it will be fixed, and K will be here, L will be here. Now what's the sum coming? -2 plus 0 plus 0 plus 2. Okay, it's also coming 0, so we will just save this answer. So the answer will be, next quadruplet is -2 0 0 2 -2 0 0 2. Alright, now we will move K and L. Now there's no need to check because K should be less than L. Here they are equal. Now again we will move J forward. J will be here now. So what do you think that we need to check again J as 0, because it was already 0? So this will cause duplicate quadruplets. That's why we will not count this. We will keep incrementing J pointer until we find a new J. Alright, we will stop here. Now we will do the same, that if nums of J was equal to the previous, that is nums of J minus 1, we will keep moving our J, or we will continue from there. And similarly we will do the same with this I pointer also. And now here we have got a new J. So now we will just keep our K and L. K was J plus 1 and L was the last element. Now K is not equal to L, so this doesn't need to be checked. Now J will be moved again forward. Now J will be here, K will be J plus 1. This will be causing out of bound, so we'll stop here. And now J loop is completed here. Now we will move I pointer ahead. I will be here, this will be fixed. J will be I plus 1, K will be here, and L will be at the last. K and L will be variable. Now checking the sum, -1 0 0 2. The sum is now +1. Alright, so this is greater than 0. So what we will do, we will just reduce L in this case. So L will be here now. Now checking the sum, -1 plus 0 plus 0 plus 1. So yes, -1 plus 0 plus 0 plus 1, this is 0. Now we have found again a quadruplet, -1 0 0 1 -1 0 0 1. Alright, so we have found one. Now we will again, what we will do, we will increase K and L simultaneously now. they have crossed, so no need to check. So we'll stop here. Now we will move our j pointer ahead. J will be here, k will be here, L will be here. Now checking the sum, -1 0 1 2, this will be 2, so this is greater than the target, that is 0. So in this case we have to reduce, so L will be here. Now it has crossed, the boundaries. Now we will again increment j. Now j will be here, k will be here, and L will be at the last. Now again it has crossed the boundary. Now j will again be at the last, k will be here, k will not be here, k will be at j plus 1. This will cross the boundary. Now we have to increase our I pointer, so I will be here, j will be here, k will be here, L will be here. Sum is 0 0 1 2, this is 3, so we have to reduce L. So these are same, we have to increase j now. Alright, now j is here, k is here, and L is here. So now we know that in this case we have to increase our I now. Alright, all the case will be are not valid. Now I will be here, j will be here, k will be here, and L will be here. Again we know in this case we will move j forward, and that will also be not a valid. So we will, in this case, now we will move I ahead. Now j will be here and k will be out of bound, so we will just move j now, so j will be also out of bound. So now we will move I at the last, and when I will be at the last, we can say that j will be I plus 1, this will be out of bound. Now I will be here, so it is out of bounds, so the loop is complete, and we can see that we have got the answer, the 3 quadruplets. Now let's verify from the answer. First is -2 -1 1, 2, so -2 -1 1, 2. All right, second is -2 0 2 -2 0 2, third is -1 0 0 1 -1 0 0 1. So yes, we have went through the dry run also, and we have solved this problem. Now next part is to just implement this, and our answer is correct, and it is written that you may return the answer in any order, so we don't need to worry about the order of these. Now we will just implement this. So first of all, I will declare the size of the nums array, nums dot size. Now what I said, we will use first of all we have to sort the array, so I will sort the array, nums dot begin comma nums dot end. Now we have to return the answer also, so I will just store the result as res. Now what I said, we will start from int I is equals to 0, this will go up to the last element, and what I said, we will skip the duplicate parts, so we will keep moving I if nums of I is greater than nums of, if nums of I is equal to nums of I minus 1, we will continue from there, because we don't want to consider duplicates. Now our next loop will be int j is equals to I plus 1, and this will go up to j is less than n and plus plus j. Now here also we will just skip the duplicates, and here I will write j should be greater than the first element, and nums of j should, if it's equal to the last previous, then we will continue from there, and if not, now what I said, we will declare 2 pointers, k will be at our j plus 1, and L will be at last. Now while k is less than L, the third loop, we will just first find sum. So I'm declaring sum as long because we can see in the constraints that the numbers can go up to 10 to the power 9. So I'm declaring sum as 10 to the power 9. Now while k is less than L, that is the third loop, now we will find the sum. I'm declaring sum as long because numbers can go up to 10 to the power 9. So sum will be nums of I plus nums of k, and sum plus is equals to nums of I plus nums of j, let's say here, and nums of k plus nums of L, and I have written sum plus equals to these two elements below because uh, if I write above they will exceed the integer range. Alright, so this is for saving the edge cases. Alright, so now here we will just have three cases: if sum equal to the target, or else if sum is greater than the target. Alright, or in the else case if sum is less than the target. So if sum is equal to the target, what I said, we will just store our result in the resultant vector. So I will say result dot push back all the quadruplets, nums of I, nums of j, nums of k, nums of L, and we will move our pointers. And what I said, we will also skip the duplicate cases, so skipping the k pointers. So if nums of k is equal to the nums of k minus 1, we will keep moving k. Similarly, while k is less than L and nums of L is equal to nums of L plus 1, we will decrement L pointer. Alright, now in the else if case, if sum is greater than the target, so if sum is greater than the target, we should reduce L pointer so that sum can reduce, and if sum is less than the target, we will increase our k pointer because it was sorted. Now in the last we can say that we can just return our result. Now let's submit it and check if we are able to pass the sample test cases, and let's submit it now. So we can see that we have solved this problem now. And if I talk about the time and space complexity, so we are using two for loops for sure. This will be big of n square, and inside we are using a while loop, and inside this while loop we can see this is the third loop. We can see that if k is here and L is here, each and every element is visiting once. So in this while loop we can say this is iterating, this is taking big of n time complexity at max. So we can say that the time complexity is big O of n cube. Alright, and space complexity, we can say, are we using anything? So we are just using this resultant vector to store our answer. We are not using any extra space. But yes, for storing this we can say that we go off, let's say, what should I say, number of quadruplets. Alright, so this was all about this problem. I hope you understood. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.